Hello students, I am Saili Rathod. Today I am here to present a lecture on digital electronics whose subject code is 204. And the topic that we are going to cover in today's video is weighted and non-weighted codes. Okay, so before moving ahead with today's topic, weighted and non-weighted codes, we will have a review that we have studied in this subject up till now. So in digital electronics, the first unit, that is the number systems. In this topic, we have covered all these topics. So first one was what is number system, means in this point we have studied that what is actually the number system, what is the need of number system. Then we have seen the classification of number systems, the different types of number systems, that is binary, the numbering system which is having base 2, that is which uses only digits 0 and 1. Then the decimal number system which uses the numbers from 0 to 9. So in all total 10 digits are used, therefore it is called as the decimal number system. Then the third one was octal number system which uses the digits 0 to 7. So the base of octal number system is 8, and the hexadecimal number system which uses the digits 0 to 9 and A to F alphabets. And the hexadecimal number system, the base is 16. Then we have seen the conversion of number systems. So in that this topic was somewhat large, so two videos cover this complete topic, conversion of number system, where in the starting we have seen the conversion of binary to decimal, binary to octal, octal to hexadecimal. Then we have seen decimal to binary, decimal to octal, decimal to hexadecimal. Then conversion of octal to binary, octal to decimal, octal to hexadecimal. And lastly hexadecimal to binary, hexadecimal to decimal, hexadecimal to octal. So all the conversions we have seen in the previous videos. Then we have seen the complementary theory, in which we have studied 4 types of complements, that is 1's complement, 2's complement, 9's complement and 10's complement. Here we have seen how to take all these complements and how to solve the arithmetics using all these complements. So all the points listed here we have covered up till now. Now we will move ahead with today's topic, which is weighted and non-weighted codes. So we will see what is meant by weighted code, what is meant by non-weighted code, which type of codes are called as weighted and which types of codes are considered as the non-weighted codes. So in today's lecture we will see only the introduction about all these codes, and in the next lecture we will see all these codes in detail and the conversion of these codes. So moving ahead with first point, that is weighted codes. In weighted codes, each digit position has a weight or value. The sum of all digits multiplied by a weight gives the total amount being presented. We can express any decimal number in tens, hundreds, thousands and so on. Okay, so weighted code means what? For an example, 8421 code, in which every digit will have a specific weight, means if 8421, then the last digit will have the weight 1, before that it will have 2, before that 4, before that 8 and so on. So in this way, by using these weights and sum of these weights, we can express the number in a weighted code. Now here we have taken an example of decimal number 4327, which can be written as 4327 equals to 4000 plus 300 plus 20 plus 7. So in the power of 10 it becomes, how we can write it, 4327 as 4 into 1000 means 10 raised to the power 3, plus 3 into 100 means 10 raised to the power 2, plus 2 into 10 means 10 raised to the power 1, plus 7 into 10 raised to the power 0, it means 1. So 7 into 1. Okay, so here we can see the example of decimal number. Now the BCD or 8421 is a type of weighted code where each digit position is being assigned a specific weight. Okay, so this type of coding system is called as the weighted code. This concept will get clear when we will solve the problems or we will calculate the actual weight of a particular number. So just remember the general definition of weighted code. In the code in which each digit position has a particular weight or value is called as a weighted code. So moving ahead with non-weighted code. A non-weighted code, there is no positional weight, that is each position within the binary number is not assigned a prefixed value. No specific weights are assigned to bit position in non-weighted codes. Okay, now the non-weighted codes are very important because the non-weighted codes, that is gray code and XS3 code, it is a very important point. Many times questions you may get on these topics. So today we will see an introduction about these codes. What is the gray code and what is the XS3 code? So now as we know BCD number and the binary number. So here in this slide we will see the comparison of BCD with binary. Means all this both systems uses 0 and 1, but what is the actual difference between these two numbering systems? So BCD is less efficient than binary. Why? We will see some examples. From this you can recognize that why the BCD is less efficient. Example is 78 decimal number. So if you want to write this 78 in the BCD form, how you will write? First we have to write the binary code for 7 and then binary code for 8. Okay, so first group of 4, that is 7. As we know binary code for 7 is 0111 and then the code for 8 is 1000. So combining both these numbers you will get the BCD code for 78. Okay, so this is BCD. And now the binary code. Now binary code, how we can write? We have to calculate the total of each digit. For an example, the answer of 78 in binary is 1001110. We have seen the conversion technique of decimal to binary. So using that system we can write down the binary code of 78 number. But the again one technique is that we know that as from 8421. So similarly if we go on left hand side, what we will get? Before the 8 we will get 16, before that 32, before that 64, means we have to double each number. So here how many digits are there? 4 plus 3, that is how much? 7. So 7 digits we have to write. As we know 8421. So before 8 it is 16, before that 32 and before that 64. So 1, 2, 3, 4, 5, 6 and 7. So here if we want 78 we can write 1 for 64. Then we have written 1, 1, 1, 8, 4 and 2. So when we make the total of 64 plus 8 plus 4 plus 2, we will get the 78. Okay, so from that table also you can find the binary code for 78. This is another technique. If you are not comfortable with this technique, you can calculate the decimal to binary as we have seen in the previous lecture, the conversion. Okay, so Here we have written both the codes in BCD and binary. But now if we see both the conversions, you can find that less number of digits are required in binary than the BCD code. So that's why BCD is less efficient than binary. So this is the first point. Now second point, to encode the same decimal number, BCD needs more number of bits than binary. Hence BCD is less efficient as compared to binary. So this is we have seen in first point. Second point is BCD arithmetic is more complicated than binary arithmetic. Okay, so while calculations, many times we can get the invalid BCD code. So that's why the arithmetic is complicated for BCD as compared to binary. And the third one is advantage of BCD code is that the conversion from decimal to BCD or vice versa is simple. This is the advantage of BCD. So this is the comparison of BCD with binary. Now moving ahead, we will see BCD or 8421 code. Okay, so it is composed of 4 bits representing the decimal digit 0 through 9. The 8421 indicates the binary weight of the 4 bits. So decimal number we have taken in the first column, and in second column we have taken the BCD code. Okay, so for the decimal 0 we have BCD code 0000 because the 4 digits it has the weight 2 raised to the power 3, 2 raised to the power 2, 2 raised to the power 1 and 2 raised to the power 0. So according to what we need, we have to write 1 at the weighted place of that digit and other places as 0. So in this way we can create this table. Like decimal 0 is converted into BCD as 0000. Decimal number 1 is denoted at 0001. Now decimal number 2 is denoted at 0010. Decimal number 3 as 0011. Decimal number 4 as 0100. Decimal number 5 as 0101. Now we will see just from this example 5. 0101 means if you consider 8, 4, 2, 1, we have written 0101. So this is the place for 4 and this is the place for 1. So 4 plus 1, that is 5. This is how we get the code for 50101. Similarly, we can we can take the BCD code for 6, 7, 8 and 9. So this is about BCD or 8421 code. Now the gray code. As we know, gray code is a non-weighted code. It is a non-weighted code in which each number differs from previous number by a single bit. Okay, now in this table you can compare the binary and gray code. So binary code, this is a basic table we can write, but in gray code you can see the difference between binary and gray code, like comparing first and second 0000 and 0001. Here only one bit is changed, that is the fourth last bit is changed from 0 to 1, means the bit difference how many it is only 1. Now in second and third it is 0001 and 0011. Here the first two and the last one, all the bits are same, only the difference is in the third bit. Okay, so in this also there is a difference of a single bit. Now if we see 3 and 4, here 0011 and 0010, here the first three bits are not changed, only the fourth one is changed from 1 to 0. It means the difference is of a single bit. Now if we see the next one, 0110 and 0111, here only the last bit is changed from 0 to 1. It means here also the difference is of a single bit. So in this way you can compare one by one and you can recognize that in gray code only the previous number is differed by a single bit from the previous number. Means if you compare upper number and the lower number, there is a difference of only 1 bit. So this is the speciality of gray codes. Now if you want to convert binary to gray, then the MSB in the gray code is same as the corresponding bit in the binary number. When going from left to right, we have to add each adjacent pair of binary bit to get the next gray code bit and discard the carry. So this is how we can convert binary to gray conversion. This we will see in the next video lecture. And the next one is gray to binary conversion. The MSB is the binary code. It's same as corresponding digit in the gray code. And the second point is we have to add each binary digit generated to the gray digit in the next adjacent position and we have to discard the carry. So these are the two conversions from binary to gray and gray to binary. So we will see this in the next video. Today we have seen the introduction about the weighted and non-weighted codes, which are the weighted and which are non-weighted, how we have to write the gray codes and what is the speciality of gray codes. After that we have seen why BCD and binary in both these numbering systems which is more efficient. Okay, so all these points we have covered in today's video lecture. So in the next video, that is video number 9, we will come up with the next topic. So till that, keep studying. Thank you.